Good morning, and I am Llewellyn King, as you heard, and it is a good morning. It's not just a rumor. I'm so delighted to be here. I hope there's enough light. I want you to see how pretty Robert Schwartz is, and I have some quite epic lines on my face that may be of interest. I mention that because in 1973, in February, I founded the Energy Daily. Of course, the end of 1973, an energy crisis broke. And in 1974, I was part of a couple of people working on a special study for President Nixon on energy options. And now we have a new energy crisis. And what is so profoundly different is we have tools now. We have options. We have talent. But most especially, we have technology. There was none available. What we knew about was coal, oil, which was in short supply, and gas, which was in very, very short supply. Today, technology expands and extends the horizon. And right at the center of the technology firmament is connectivity, the ability to hook up, to connect, and to use data, which is the new sinew of life, which keeps everything together and promises a very bountiful upland of sun and hope for the human race. In this firmament, a key player is Robert Schwartz, who is the Chief Executive Officer and President of Anterix, a very special kind of company with a very special place in the future of the utility industry, binding it together with a communication system that is without parallel. I would like to welcome you, Rob. You can correct everything I just said, but please do so politely. I may want to work again. Well, now you're here. Welcome.
Thank you, Llewellyn. It's a pleasure to be here with you and an honor. And thank you to the Digital 360 team, Andres especially, and Cedar for having us here together.
Rob, I wanted to start with a high-level question that I think can help frame many of the discussions that we are going to have. From your perspective, as the leader of Anterix, of this company that I've described, that is trying to revolutionize a key element of the national grid, what do you see the impact of your company, your technology on this industry?
Thanks. Well, it's tying together some of the thoughts we heard this morning. It was great to hear the breadth of visions from different areas. We're really facing what we talked about as a not so perfect storm. The collision course of elements that our nation's infrastructure and specifically our nation's electric grid is facing collectively. When you think about the new environmental realities, the challenges with increasing weather incidents, unfortunately man-made challenges as we're seeing both wildfires and increasing temperatures, or experiencing as recently as this weekend in California. Texas has unfortunately considerable experience going back to 2021. That combined with the cyber realities, the aspects of increasing incidences that are occurring from both foreign and domestic actors, the number of, we've talked to utility leadership, they're seeing millions of hits on their networks on a daily basis. And so the number of challenges that are being raised to our infrastructure from that. And then lastly is the optimistic side, but the decarbonization goals that have been set, starting at a federal level, down to all of the public and private companies that are part of this fabric of our energy system across the country. It's a great thing to see, but the objectives are very high, and their ability to meet those relies on some pretty substantial changes And at the root of that is the electrification of key industries. We're seeing it across sectors, but it's going to continue to increase our reliance upon our nation's fabric of electric grid. You know, one of the most complex machines that's out there, but the technology that supports it is absolutely in need of considerable improvement to support all of these growing realities.
Rob, you said that data is important. I have said that data is important. In fact, it is often referred to as the new oil. And if you look back to that time in the 70s of the first big energy crisis, oil was the big enchilada. Today, data is the ability to manage DER, to manage small systems, integrate them with large systems, to move very quickly from one situation to another, and at all times for a utility or for an independent systems operator to know what is going on, what resources are available, and to engage those resources in fractions of a second. How do you see all that working?
You know, I think it was said earlier that data is the lifeblood of you know, the decision making and being able to manage systems. You know, data is a series of ones and zeros, right? When you get to kind of the root of it. I think of an anecdote. I was in a utility network operations center a few years back, and they were responding to an outage. And you know, they have like any good control room, have boards in front of them, and the red dots are starting to appear where they're getting reports that individual customers like you and I were unable to you know, plug in things that they're used to doing, unable to have power. And when I inquired about kind of how they were getting that information, where the data was coming from, it was inbound phone calls to their customer service center, meaning the only way in which they were able to have the situational awareness, the awareness that power was going out, was inbound calls from users on their cellular network, outside of their own infrastructure, to be able to report that. And it's important because that's the beginning of the data that we're relying on to respond. Whereas I've spent 30 years in the wireless area. We have our executive chairman, Morgan O'Brien, here. They're the founder of Nextel, one of the beginning of my roots in the wireless space. And you know, even in those days, we had a level of situational awareness of our networks out to the individual users, to the subscribers. Every single cell site, every single element, we knew if it was working or not at any given time. Whereas the electric grid, in the example I gave, are relying on hearing inbound calls, sending a truck around a neighborhood to find out, in this case, it was eventually where a branch had fallen on a wire and broken a wire, and be able to then go and deal with it. The future of data, to take it to going forward, and especially in these infrastructure, is having the level of situational awareness where you can have sensors deployed throughout these networks, right? Data is only as good as what you're capturing. So I think it was said earlier, you've got the data, you have the transport, and then you have the analytics. Without the transport, you can't have the data. And so the essential nature of having low-cost, highly ubiquitous, very secure networks to support this is essential. The good news is the technology exists, right? We all have it in our pockets. The LTE, the 4G, 5G technology, the global standard is what's allowing consumers and enterprise to be able to have this kind of connectivity. We now need to embrace and allow our nation's electric grid to have that same level of resiliency and security to be able to solve these big problems. And the data at the end of the day is what's going to allow us to be able to make these kind of assessments of situations and in milliseconds be able to make changes that save lives, right? These are things like wildfires that we can prevent. If you can tell that a power line has been broken and can turn it off in the roughly 1.4 seconds it takes before it hits the ground, that'll stop a wildfire. What's the value of that happening once, let alone happening multiple times? What's the value of being able to know where power is being used and where it's being consumed at any given time? That's data, and the ubiquity of that data and the availability and decisioning off it is essential, and that's where we have to go.
Thank you. I think we have a slide from Ashad Mansour, the president of the Electric Power Research Institute. Do we have that slide? Anyway, if we don't have the slide, or it'll appear. Oh, good. The thing about Ashad told me that with the use of data, they can wring so much more power can be wrung out of the existing system. Even an old dam, he said, can multiply its effectiveness, produce more power by 1 to 5% using data, managing it correctly. David Naylor, who is at the here in Texas at the Rayburn Electric Cooperative, is working on DER with his largely residential load. 90% of his customers are, or that utility's customers are residences outside of Dallas. And yet they are hoping, using data and DER, applying it to the residents, that they can get an improvement of 10%, an enormous gain just from the use of data. No more hardware, no more lines, just the intelligent use of the system they have because of superior data. Rob, where do you think the industry is going? How quickly has it recognized the need for data? Is it really up to speed? One of the things that holds back the industry is that it has to keep the lights on. Maybe not on this stage particularly, but in general, it has to keep the lights on. And that is a real-time responsibility, which makes it much harder for an electric utility to think forward, to shut down, to reorganize. It cannot do that. It has to change on the fly. Where do you fit into that?
It's a great question. So, look, change takes time, especially in essential services, entities like electric companies and other critical infrastructure that are required, as you said, to maintain a level of capability and resiliency. But just like IT, and IT I think is a great example where, you know, it used to be the guy who kept the computers running in the basement, and now it's strategic. It's in the boardroom. It's a competitive advantage globally. It's an important element of how we analyze and process data. But the connectivity piece, the telecom, the transport, as we called it earlier, is without that, it's like having an islanded capability of computers and processing without an ability to really have that situational awareness that's essential. And so we're seeing, the good news is, I think, the beginning of a revolution, the recognition of the need for this level of resiliency in communications. And I know we're joined by a lot of partners here in the room and probably on the internet as well. What we're doing with CEDAR, for example, to demonstrate the importance of this communications across applications, right? This is just like the phone in your pocket again, right? You got that phone to make phone calls and maybe make text messages. Now you've got so many applications on it, you probably can't even keep track what's on that phone. You're balancing your checkbook, you're ordering taxi cabs, you're managing all kinds of things that you never thought you could do. This convergence onto a single technology is the same thing that should be happening, and it's starting to happen with utilities. The good news is we're seeing the support, and we've got a number of utilities that have stepped forward, leaders, Southern Company, Ameren, Evergy, San Diego Gas and Electric, and others, as committed to deploying these private broadband resilient networks for all the right reasons, and solving dozens of use cases. That's the important part, is that this is crossing across organizations. Typically, we used to put out a single purpose. You know, we needed light in the room, we put in a light bulb. But now we've got a network that is solving lots and lots of use cases. And we're seeing a broader support from groups like the Utility Broadband Alliance, which we're proud founding members, and I know Ericsson is here in the room, also an important player from both the Texas state, but also from their capabilities in helping drive the solution set to be able to build this capability. We're seeing now, I think, over 16 members of utilities, making up over 70 members of the UBA environment, the Utility Broadband Alliance. We're also seeing over a dozen experimental licenses that are out, including the one here at Texas State, to be able to show the diversity of capabilities that this broadband, private broadband networks can enable for utilities. And it's an essential piece of that communications. And lastly, I think we're seeing, and I think we heard some of it earlier, is tremendous support from the federal government, right? Again, the infrastructure legislation, right? The being able to have funding to drive the resiliency of our electric network. It's being, it has multiple purposes. It's driving broadband connectivity into rural areas. It's adding resiliency. It's has life-saving capabilities through its capabilities with wildfires and other areas. So at this point, I think, well, into long answer to your question, I think we're seeing the seeds of the beginning, but it's really a time for a call to action for the rest of the industry.
I'd like to drill down a little bit into Anterix and what it offers a utility. If I was sitting in the C-suite of a utility and you came through the door, what would you be offering me that I need, or maybe that I don't know that I need?
Thank you, and thanks for the opportunity for a shameless plug here. But Anterix, as a company, we are enabling utilities to build and own and operate their own private communications network. We happen to have ownership of a very valuable swath of radio spectrum, low-band spectrum, that is the lifeblood of being able to connect up networks, LTE networks. And so as we talk to utilities, and we're doing a lot more than providing the spectrum, we're really trying to bring together the ecosystem. We've launched something called the Anterix Active Ecosystem Program, now with over 80 members, several of them here in the room with us, because it's not about just the spectrum, it's about the solutions that it's solving. And so as we're talking to utilities that are focused on solving cybersecurity issues, we're solving these decarbonization issues with increasing sources of energy that are distributed, or if it's about the new environmental challenges, private LTE is a big part of the solution.
When I talk to the CEOs of utilities, and I talk to quite a few, the one thing that they all tell me, the standard answer when I ask them, what keeps you awake at night? The answer is cybersecurity. Can you help them with that?
Absolutely, absolutely. And so, there is no one silver bullet. It's an evolving threat landscape. However, there's some fundamental elements, that's been pointed out in several federal government reports about the need to have a network that is separated from the public internet as a vital first start. So building private networks that you're not utilizing the same networks that any actor, especially some of the threatening foreign actors, can go to a corner store and buy a device and be on the same network. That's an important first step. But using the global standard of LTE technology inherently has considerable cyber security capabilities, and importantly, the ability to customize. And we're working, I mentioned the 80 companies in our ecosystem program. There's a half dozen companies in there that are actually driving incremental layers of security. And so when you build your own private network, you can build it as secure as you desire. And that's really the compelling aspect that the chief information officers, the chief technology officers are seeing as compelling as part of the private network, and why Anterix's solution makes sense for them.
Rob, I've heard you talk about network of networks. What is the network of networks? And where does Anterix, with its 900 megahertz base, fit into that?
So if you think about a U.S. map, and any utility is really defending their castle, their service territory, the border, and so they have to put up all of the systems to support their customers, the electric needs within that footprint. But there's a commonality of issues across the nationwide landscape, and that's part of what we've been doing in bringing this ecosystem together, in solving these problems collectively. The term the network effect, which basically says every incremental element, it was really originated back to the internet idea, but every incremental utility that we add to this network adds to the benefit, the value that each of the incremental utilities get when they're together, because it drives development. It attracts, as we have now with the 80 entities that are part of this ecosystem, it attracts development of solutions, and it really makes it, importantly, evergreen, right? The nature of technologies in the past that a lot of utilities and other critical infrastructure have relied on, they've been often custom one-off technologies that reach dead ends. And then so you end up with legacy networks. One of our customers, Ameren, has over 20 different existing legacy infrastructure, wireless infrastructure systems that they're going to migrate onto a single ubiquitous, resilient secure network. And so the network of networks brings that capability to all infrastructure, critical infrastructure users, especially electric utilities, to be able to leverage off that growth and development rather than letting any utility have to figure it out themselves. It says, let's do this together and solve this as a nation to be able to reach the important goals of cybersecurity, decarbonization, and dealing with new sources and distributed energy.
The ecosystem of, of companies, this is very interesting. These are companies that compete fiercely, basically 80 competitors. Maybe they don't all compete in every arena. How do they nestle together in this aviary you've created?
You know, it's fascinating for me to watch because you're right. There are arch rivals as part of that group that do come together. Most recently brought the group together during Distributech, the big annual technology show for the utility industry, and to see 75, 80 of these companies together in one room, because what they realize is the need to solve this problem. And right, solving this problem for their own economic interests is clearly, brings forward the opportunity collectively. But at the same time, I think it's an acknowledgement that we can't solve the scope of this problem if we don't do it collectively. And that's really what the ecosystem is meant to drive. And I respect all the companies for the willingness to come together. And really, I think a big part of it too is how do we collectively help these entities, electric utilities, to understand an area that they weren't built to understand, right? They're phenomenally brilliant at managing megawatts. They're not phenomenally brilliant yet about managing through megahertz, right? The spectrum and the frequencies and the communications technologies. But it's no different than IT was 10, 20 years ago, where none of us had to understand how computers worked. Now we all have to, right? It's an essential part of any enterprise, any public or private entity. And so now telecom has become exactly that. It's really part of that IT fabric. And so the essential knowledge base that we've come together as this ecosystem to help utilities understand and provide them a roadmap collectively. So I'm most excited about that, is how do we bring the industry collectively together as part of this network of networks to solve these big problems.
What is the virtue of a, quote, private, unquote, network, as opposed to just a network? Everybody's on some network today. Could you explain the significance of the privacy aspect?
Sure. And so it does start where you asked before with security, cybersecurity. So being separate, air-gapped from the public internet is an essential nature in today's day and age to be able to be a secure network. When we first put up communications networks 10, 20, 30 years ago, and often we go into utilities and they're operating networks that are 30 years old, that wasn't a thought. And so they're on spectrum that's being shared with other entities. They're using technologies that are basically porous. You could, your kids probably have equipment that could almost listen in almost any of this communication, or unfortunately block or change the communication. So the security of it's a key part of it. It's also the resiliency. You look at the networks that have been built. Southern Company is a great example in Alabama and Georgia. They've built their communications network with a level of resiliency to handle the level of storms and the level of challenges that they see in their environment. Commercial networks aren't built for that. They're built to provide good and great services to consumers and enterprises as available when needed. But in the moments when they're needed the most, when storms happen, when crises happen, and those networks get congested, or in worst case they go down, that's the challenge. And so you have to build these networks at a level of resiliency that electric companies are used to building, but you can't use a commercial network that's built for a consumer level of capabilities.
That's very interesting. I remember, I think it was 4 years ago, when the current cycle of wildfires was really getting underway in California, and Pacific Gas and Electric was isolated. The state couldn't get through because they got too many conventional telephone calls, and essentially the switchboard or its equivalent was unable to cope. Customers couldn't cope. They were being blacked out and they didn't know, and they were calling in saying there's something wrong, we have no electricity. You're going to be able to solve that, I assume, with tremendous amount of data. Everything is now going to be, are there any downsides to the data flow?
I think the biggest challenge, as I mentioned earlier, is the lack of visibility, right? With more and more assets being deployed, right? We're in an environment where solar, wind, battery storage, small nuclear capabilities are going to be deployed throughout these geographies to solve these energy usage requirements. And if we can't see those devices, if we can't communicate with them, if we're deploying solar on residential rooftops, but we don't have the ability to know when it's being generated and when it's being consumed, then we won't have the ability to be able to collect that data and therefore decision off that data. So to me, the data aspect is, the technology of how we decision off the data exists. It's incredible that what's happened in cloud computing, both centralized and edge computing, and so all that capability is there. But if we can't get to the assets and understand what's happening, then having that capability doesn't really help. And so that's where I think the data situation really needs the most focus.
I have mentioned that EPRI and Rayburn, a small Texas rural electric cooperative, are looking to see much more productivity out of the system without new generation through data. Do you see that? And what is your estimate of the productivity that can be wrung out of existing generation and transmission with better data flows?
Yeah, I mean, I guess it's overstated. Knowledge is power, right? I mean, the expression of, if a tree falls in the forest and there's no one there to hear it, does it make noise? If that tree is falling on a power line, it may not make noise, but it's starting a fire when that wire hits the ground. It puts someone's life at risk. It's taking power out of a community that may need it, and it could be life-threatening. And so, EPRI really has shown incredible foresight. You mentioned Arshad Mansour earlier, right? The acknowledgement that we won't be able to build the level of capabilities, which includes having this understanding of data. And with this understanding, absolutely, we can run our grids much more efficiently. I've seen numbers 10, 20%, just off the bat. When you think about the amount of energy, and unfortunately, as we sit here in Texas, the experience in February of 2021, a lot of that had to do with a lack of situational awareness, not having the ability to control assets remotely, not having awareness of where power is being generated, not having a communication systems that brought all of these disparate assets together with a level of control and integrity. And so I think at the root of a lot of these challenges we've seen in the past 5, 10 years, and unfortunately we're going to continue to see until we are able to build a resilient level of communications, secure, private, to allow us to have the level of control that we're going to need of those networks.
Rob, to get to this data nirvana, what kind of hardware is needed? What would a utility using your system have to build out?
It's the same kind of technology that's being utilized by wireless carriers across the globe. It leverages to start the infrastructure they have in place. Typically, utilities have their own fiber, their own assets of towers that they're using for transmission and distribution, and so that's the beginning of it. Then you're overlaying new radio equipment. That's the lifeblood of this. The good news is there's great vendors that around the globe that make this equipment, many of whom, including Ericsson, again, who's here in the room. To me, it's the technology is not the challenge, right? There are lots of great vendors. It's well proven. It's about the integration to the network and the acceptance. The other thing is the business case, which I think is kind of the next step of the question, which is, yes, it's an expensive network to deploy. There's no way to skip that. But when you look at the cost versus the benefit, it's obvious. We've seen utilities that have justified it just in cost reduction, consolidating existing networks onto their systems. But when you look at the benefit of being able to drive greater efficiency in their networks, being able to stop incidences of wildfires, respond to storms, be more resilient, stop cybersecurity incidents, those are billion-dollar issues, multi-billion-dollar issues, and life-saving challenges that the cost benefit is crystal clear when you get through the right level of analysis.
Rob, we're coming towards the end of our time together. what else would you like to tell me? I've always found as a journalist, it's the big bland question that gets the scoop, not the bang bang, what have you got to hide question. So tell me, what would you like to tell me?
I think this is an exciting time in the sector, right? I painted a lot of the negative challenges, but I think on the positive side, and we heard some of it this morning, I know we're going to hear a lot of it. I'm looking forward to hearing what's going to be discussed on the panels going forward. The level of opportunity of leveraging our nation's electric grid for all of the great benefit of decarbonization, of reducing our consumption, being able to use it for electrification of new industries, the AI capabilities, the automation capabilities. Having spent my career in the wireless space and now really waded into this space deeply, I'm very excited about the opportunity. It will require a level of collective action. We're going to have to work together to be able to solve these big challenges. But with that solution, I think it's going to, the opportunities are endless.
Rob, thank you very much for being so candid and outspoken. I would just like to add something which you cannot add, and that is one of the great benefits to the electric utility industry of the incorporation of data and people who handle and deal with a whole world of data is there has been, sir, an enormous influx of talent into the utility industry, much needed, and it does offer a new day, and if I might, I include you among that talent. Cheers.
Thank you, Alon. Thank you, everybody.